Hello friend, welcome to Technovizar. This is Rohit Sharma and this is our video number 7. This video is based upon the number system conversion in digital electronics. Okay, number system conversion. Before this we have completed logic gates and the Boolean algebra expression and network theory we have already completed. Okay, so those students who are new, first of all I have given the links of these channels. Okay, you can follow them to prepare for various exams like ISRO TA, SSC, JE, NPCL, etc. for electrical and electronic students. Okay, so so please, those who are following this 45-day strategy, please don't forget to subscribe the channel. Please subscribe the channel so that you can get new notification of the video. And also ISRO TA crash courses are already available at Mechanical Adda app, and where well explained concepts are there, good number of questions are there, 180 plus videos are also there. ISRO TA test series is also available, subject wise courses are available at Technovizar app, and quiz tournament that is going free of cost at Technovizar app. So you can go and avail these crash courses at Mechanical Adda app and subject wise courses at Technovizar app. Okay, so let's start the video. So decimal to binary conversion first of all. So this is a decimal number, you have to convert it into binary. So for this question you have to divide 12 by 2. Now 2 6 are 12 and you will get remainder as 0. Okay, now 2 3s are 6, you will get remainder as 0. Now 2 1s are 2, you will get remainder here as 1. Okay, so for this you will again you will divide this, you will get 1. This will be like this, MSB to LSB. So when you convert 12 into binary, you will get 1100 in binary. Okay, now if it is in point form, you have to convert this decimal number in binary form. So you have to multiply 0.75 multiply by 2, you will get 1.50. Now from here you will get 1 as the number, and 0.50 again you will multiply it by 2. So this will be 1.00. Now this will be 0.00. Now you should stop here, and the binary number you will get as 0.112. Okay, this is the binary number here. Next is 251, that is an octal. Okay, and this is decimal to octal. So here this is this is a decimal number. Okay, sorry, this is a decimal number and you have to convert into octal number. Okay, for this you have to divide 251 by 8 because you have to convert it into octal number. Now on dividing it by 8 you will get 31 and 3 as the remainder. Okay, again when you are dividing it this by 8, you will get 8 3s are 24 and 7 as the remainder. So MSB to LSB, so 373 in octal. So you can write 251 which was in decimal as 373 in octal. Okay, so this is how you can convert these type of number. Now next is decimal to hexadecimal. Okay, so 351, that is in hexadecimal, you have to convert it into, sorry, this is in decimal, I have not changed the numbers, sorry, this is in decimal, you have to convert it into hexadecimal. So you have to just 351 divide by 16 because you have to convert it in hexadecimal, and hexadecimal is of 16 bits. So 16, when you are dividing it by 16, you are getting 21 and you will get remainder as 15, and in hexadecimal we read 15 as F, so I am writing F. Okay, again when you are dividing it by 16, okay, you will get 16 ones are 16, okay, and remainder as 5. So from here you can write 15F, that is MSB to LSB. So 15F in hexadecimal number. So the 351 which was in decimal number, on converting into hexadecimal you will get 15F as the hexadecimal number. Now we have to convert binary to decimal. So this is binary and you have to convert in decimal number. So 1101.011. Okay, here this will be 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. Okay, and here this will be 2 to the power minus 1, 2 to the power minus 2 and 2 to the power minus 3. So on multiplying this you will get 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. So 1 into 2 to the power 3 is 8, this will be 4, 0 multiplied by anything is 0. So 1 into 2 to the power 0, 8 to the power 0 is always 1, please remember. So this will be 1, plus 1, 0 into 0, this will be 0, plus 1 into 2 to the power minus 2, this will be 1 by 4, plus this will be 1 by 8. On solving this, you will get 12 plus 1 by 4, 8 plus 4 plus 1, 12 is 13, this is 13, 13 plus 1 by 4 plus 1 by 8. From here you will get 13.375 in decimal number, okay, decimal number. Next question is, you have to convert 341, which was an octal, to decimal. So here 3 into 8 to the power square plus 4 into 8 to the power 1 plus 1 into 8 to the power 0. So 8 to the power square is 64, 3 into 64 plus 32 plus 1. From here you will get 225 as the correct answer in decimal number. This is how you can convert these type of number. Now hexadecimal to decimal, same, 1 into 16 square plus a into 16 power 1 plus 2 into 16 to power 0. So this will be 16 into 16 is 256 plus a is written as 10, 10 into 16 is 160, okay, 256 plus this will be 2. From here you will get 4118 as the correct answer, okay, in decimal number when you are converting hexadecimal to decimal, okay. So now is second one is next one is binary to octal number. So here this is given as, this is the binary number 11011.1011. Now you have to convert it in octal. So let's see this. In octal, you know that 2 to the power cube is 8. So this is a 3-bit number, okay. So I am taking 3 bits like this here. So 1 bit is, I am taking this as 0, okay. So again this is a 3-bit and again I am taking 0, this, like this you can convert this. 011 is, this will be equal to 1 plus 2, 1 to 48 conversion, okay. So 1 plus 2 is 3, this is also 3, 0.101 is 5, 100 is 4. So 33.44 in octal. This is how you can write binary to octal number. Next one is binary to hexadecimal, 11011.1011, okay. So in this you have to convert in hexadecimal number. So 1 second, let's see, and separating these like this, and 1 second, this is 1101 and 1011. This is how you can write this number. I am taking here 000, okay, and this is already a 4-digit number. So this is 1. 1011 is 1 2 4 8, 8 plus 2 9 10 11. Now in 11 you can write it as 11 is B, okay, 0.1011, this is also B, 1B point B, you can write it as in hexadecimal number. You can write this binary number like this, okay. Next is octal to binary, that is 375.6, जो आपको octal में given है. This is given in octal, you have to convert it into binary, okay. So this is simple, just you have to write this as in binary. In binary you can write 3 as 011, 7 as 111, okay, 5 as 101, 0.6 as 45110. So this will be in binary. This is how you can convert these type of numbers. Now next one is hexadecimal to binary. 1 second, I have to double. Okay, so this is 5AB.6, that is in hexadecimal number. You have to convert it into binary. So this will be a 4-bit number. 2 to the power 4 is 16, okay. So 5 can be written as 0101, A can be written as 1010 because it is 10, and 11, B is 11, so B can be written as 1011, point C can be written as 1100. This is a binary number of this hexadecimal number, okay. So next is octal to hexadecimal number, 375.6, that is given as octal number, and you have to convert this in hexadecimal. For this type of question, first you have to convert this in binary. On converting this in binary, 3 can be written as 011, 7 can be written as 111, 5 can be written as 101, 0.6 can be written as 110. Okay, so I am separating them. So this separated, this is also separated, 0 0 0 0 here, or you can say simple here also 0. So 1 1 1 1 1 is, it is 15, that is F. 1 1 0 1 is 10 11 12 13 13, this will be 13, so this will be D. Point 1110 is C. Okay, so this is a hexadecimal number of this octal number. So always remember, if you want to convert octal to hexadecimal, first you have to convert octal to binary and then binary to hexadecimal number. Okay, so next question, hexadecimal to octal. Same for hexadecimal to octal also, you have to convert this into binary first and then binary to octal. So on converting this will be equal to 0101. B can be written as 1011. 8 plus 2 plus 1 9 10 11 dash 1011. Point D can be written as 1101. Okay, now I have to write it in octal, so to the 2 to the power cube. So see this, one pair, second pair, and I am putting 10 here. Again one pair, I am putting 20 here. So 001 is 1, 011 is 3, and 011 is 3. Point 110 is 1 2 4 5 6. 100 is 4. 133.64 is the octal number of this hexadecimal number. So these are the conversion number system conversion that are in your syllabus, and you can have question on these topics. So I have explained each and every conversion with the help of one example of that conversion. So please remember this, very very important. Okay, and please watch this video again and again so that you can buy ahead these conversions, okay, for your exam. So okay, then we will meet in the next video for combination based on combinational circuit for digital electronics. And those who have not subscribed the channel, please subscribe the channel. And okay, then take care of your health and all the very best.